All right, our objective for today, can graph and write absolute value functions. Copy the objective really quick. You don't need a Frayer model since we already know what functions are, right? Tell your neighbor one word that would trigger a definition for function. What would be one word? Relations is correct, yes. One-to-one or something like that, yeah? All right. Today what we're going to do, since we covered most, if not all of the graphing, page 71 for the home plate will be a piece of cake because you know what to do for graphing. But today I just want to do an exercise in regards to see if you see what I see. Because it's something that I want you to see. I'm telling you, right? So, you say PJQ? Yeah. All right. So, and actually, yeah, I have my turntable. You guys know that? I have my turntable on my computer. My turntable. Let's go. All right, so functions, we already know what those are. And I'm going to start with this one. Writing utensils down, look up to the screen. Here we go. So, by now, if I was to give you a function such as that one, we know the transformations that we have in front of us. However, in case we forgot, here goes part of it. If a number is in front of the function, such as 4, and it's a whole number, that number will stretch or compress. However, in this case, if it's the whole number, it's going to stretch, and it's going to do that vertical. The other thing, H will tell us to go either to the left or right. In this case, it's going to the right 5 steps. And K out here is going down 2 steps. From there, we can identify that the vertex is 5, -2. Are we there? Okay. Any questions up there right there? Okay. So what I want us to do next, I'm going to send you the screen, lock it toolbar, and I want you to write me on the screen what each part of the transformation of that function does to the graph. Ready? Just like what I did right now. I want you to write me what it does. Ready? Go. Copy that and go. So far, so good? All right, here goes another one. Lock it toolbar. Careful with this one. This one has a little curveball to it. Don't rush. And this is very similar to one of the ones from the home plate. Copy that and go. Okay, look up, guys. Here we go. So, here was the curve on this one. Look up. So, first of all, K tells us to go down. Okay, we got that. However, the vertex, pay attention to this part, vertex is 5, -3. Some of you are like, what? Notice that this one is different because now, instead of just being this, now it has a number next to the x. When that's the case, we write 2x minus 10 equal to 0, and we solve for x. That's going to be our h. That was number 8 on your home play last night. Here we go. Plus 10 plus 10. 2x equals 10. Divide by 2. X equals 5. And that's our h. You're welcome. Go. Yeah, go. All right. Wow, Zach. They're right there. All right. Anyways, so once again, if this is +5, that means this is going 5 steps to the right and 3 steps down. Yes? However, does everybody know what happened here? Yes, we need to solve for x, and that will be our h. All right. So let's see if you can do one by yourself now that you remember. Lock your toolbar. Copy and send it in. Ready? Go. Okay, let's see. Nice. All right. So you got something like this?
Oh, I don't have to write something.
Yes. It does have letters and numbers. Oh. All right. So, next part. Writing utensils down, look up to the screen. For this part, now that we know the transformations, we're going to start with the vertex. Now, here goes the idea with the vertex. Look up, please. We start with the vertex because the vertex takes care of the movement left to right, up and down in one point. So what is the vertex on this one? 5, -2. If I go to 5, -2, that took care of moving the original function 5 steps to the right, 2 steps down, just by placing the point of the vertex. Do you agree with that? Okay. Now the only thing we need to worry about is if there's anything compressing or stretching. So what is that going to do? Stretch it. So that means it's going to look something like that. Does it need to be exact? Not for right now. I just want to see if you can actually picture it. Everybody with me so far? All right. So let's see. That was me. Let's see how. Let's see. Yes. Right. See how you do with that one? Lock your toolbar, plot your vertex, and sketch me what the function will look like. Ready? Go. Copy and go. Correct answer. Why is it upside down? Because it has a negative. 2 stretches it, and it's 9 steps to the left and 3 steps up. 9 to the left, 3 steps up. Angela, you got something like that? Okay. All right. So, look at this one. Pay attention, please. Hold on. Look up. Careful with this one. It has a little curveball. Ready? Plot your vertex and sketch me what that function will look like. Copy and go. Look at it. Hands if you got that. Yeah, we got this, yes? Remember, whenever there's a coefficient on x, you need to take whatever's inside, 2x minus 10 equal to 0, and solve for x. That would be your h. Okay? What's that? Yes. All right. So, yeah. Yeah, it opened up because it stretches horizontally, and we'll talk about the value of b and a. All right. So now that we have that, send a gopher to come get a graph paper for your own. And then once you get it, copy example 4 on the top left of the big graph, please. Copy that. So copy that, and once you copy it, plot the points and graph your function. Okay? And then from there, wait for me so we can do the last part together. Okay? All right? All right, here we go. So, by now, you should have copied the table, plotted your points, 1, 6, 2, 4, 3, 2, 4, 4, 5, 6. Graph your function. There you go. Hands if you got something like that. Okay. You're like, Mr. Q, this is a piece of cake. Yes. For your home plate tonight, being that this lesson was the first lesson of the graphing absolute values. It was the first one, but I left it till the end for a purpose. Everything has a plan, right? So the first part will be a piece of cake, page 71. However, the last part that I'm going to do right now is what you're going to have problems with. Okay? So I need you guys to stay focused. Here we go. First things first, did we plot our points? Yes. Did it graph? Yes. Now, in the home plate, they're not going to ask you to do the plotting or the graphing. They're already going to give you a graph. They're going to ask you to write a function from it. Okay? Here goes the process to writing a function. Writing utensils down, look up to the screen. First things first, the very first thing I do is identify the vertex. Tell your neighbor the vertex, please. So the very first thing I identify it, on my graph that they give me, I'm going to place a point in green or highlight it, and then I'm going to write the coordinates. The coordinate is 3, 2. I can also find that in my table. All right? So, from there, writing utensils down, look up to the screen. So the very first thing, we got it. There it is. The second thing then we need. The second thing we need to know is what happened from the original function to get this function. You're saying, what does that mean, Mr. Q? This is what they gave you. No. You need to think of it in terms of the original absolute value function. What does that look like? Let's see if you can picture it. Look up to the screen. Can you picture it right here? The original absolute value function without any transformations. It's here, 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 here. That means it looks something like this. All right? So, bless you. So, aside from moving it, what else happened to it? Everyone. It stretched vertically, right? So what does that mean in terms of our formula? Look up to the screen. G of x equals a f of 1 over bx minus h plus k. Let's see. Which one stretches it vertically? A. So why did we need to know that, Mr. Q? Because that's going to be our aim for this problem. We need to solve for A to see what was the factor that we stretched it by. Do we need to worry about B? No. How about H? No. How about K? No. All right? So here goes the process. Ready? What is our aim for this one? A. All right? Writing utensils down. Look up to the screen. So by now you should be familiar with this formula. Yes? Yeah. However, that's the general formula for transformations. However, this one, or this function, is no longer a quadratic. It's an absolute value. So instead of parentheses, I do what? Absolute values. Since I don't need to worry about B, I just bring down the x and the minus. Tell your neighbor what goes here and there. Tell your neighbor, please. Daniel, what goes here? 3, and here? Plus 2. Tell your neighbor where I got that from, please, once again. All right, very good. And from there, I bring everything else down equal to A and G of X. Copy that, please, up to write down. Next, in the home plate, they're not going to give us a table. They're just going to give you a graph. So here goes the next part for the solving for A. Look up to the screen. You'll finish copying in a little bit. Here you go. Everybody understands what happened from here to here. Is that correct? All right. So what happens after this, Mr. Q? Let me show you. Write any pencils down. Look up to the screen. Some of you are like, why did he leave X and Y in blue? Talk it over to your neighbor. What do you think is going to happen after here? All right, so here it goes. For those of you that don't see it, let me connect the dots. Ready? I needed to change it back from function notation to Y form. Why, Mr. Q? Because now we can actually use an X and a Y value to, at the end, just solve for A. Where can it get an X and Y value? From the graph, one of the points. Which point do you want me to use? This one, that one? We can't use the vertex because we already used the vertex. So it doesn't matter which, right? I'm going to use this one right here. This one is 1, 6. So X is 1, Y is 6. So here I go 1, 6. I bring everything else down. Is everybody following this right there? Okay? And from there, the rest of it is a piece of cake. We just need to solve. Here we go. 6 equals A times the absolute value. What is 1 minus 3? Negative 2 plus 2. 6 equals A times, what is the absolute value of negative 2? 2 plus 2. Let me simplify this because I don't like having the variable in front of a factor. So what is A times 2? 2A. So I'm going to rewrite this. 6 equals 2A plus 2. Do we know what to do from there to solve for A? Yeah, so we subtract 2, subtract 2. 4 equals 2A, divide by 2. 2 equals A. And now that we have A, we're going to substitute it in here. Where, Mr. Q? Right there. That means I'm going to rewrite this over here. And our function is g of x equals 2 times x minus 3 plus 2. Copy that, please. All right, here it goes one more time. Look up to the screen. Here goes the process. They're going to give you a graph. From the original function, you need to figure out what's happening here. You're saying, well, it's going to stretch because the movement, I can see it with the vertex. What was the movement? 3 to the right and 2 up. That's why it ended up there. So that's why we only need to worry about A. Once we get that, we write our general formula. Since we're not focused on B, we're imagining that B is 1 and 1 over 1 is 1. So we just write A so we can focus on A. We substitute the vertex, there it is. Then we change it to Y form in order to substitute a point in here. Did it matter which point? No, I usually go with the first one, but it doesn't matter which point because all points have what? An X and a Y value. Once you substitute the X and Y value, simplify and solve for the variable, and that's how we get that value and substitute it there. Okay? All right. Now check this out. That's if the function looked like this. What if the function, look up please, looked like that? It's stretching, but in which direction? Horizontal. So are we going to focus on A? No. We would focus on B. That is correct. So you would write, oh, for that one, I'm going to focus on B. That means I don't have to worry about A because we assume that A is 1. Everybody with me? All right, let's see if you can do one by yourself. Here we go. Lock your toolbar. You can use the same graph if you want, but if not, use the little ones in the back. Example 5, it says plot the points, then graph your function and write your function. There it is on your screen. Copy and go. All right, let's see. So I'm going to graph this, -7, -2, -6, -6, -5, -10, -4, -6, -3, -2. So my function looks like that. Hands if you got it to right there. Okay? From there, what do you guys notice? That it's stretching, is that correct? And we're going to worry about A. Therefore, I would write G of X equals A F of 1 over BX minus H plus K. But now since we have absolute value, we're going to focus on A. What was our vertex? Our vertex was -5, -10. So that goes right there. -5, this becomes a +5, -10. Hands if you got up to right there. From there, we pick a point. Doesn't matter which. I'm going to pick, let's see, -6, -6. All right, so I'm going to substitute in here -6, -6. And of course, after changing it to y, this is A times the absolute value plus 5 minus 10. This is -6 equals A times absolute value of -1 minus 10. -6 equals A times 1 minus 10. So this is -6 equals A minus 10 plus 10 plus 10. 4 equals A. Therefore, my function is G of X equals 4 times the absolute value, X plus 5 minus 10. Hands if you got that? Yeah, so just be careful with the ones that are stretching horizontally that you need to focus on B instead of A. Okay? Have a good one, guys. Once again, home plate is on page 71. And 72, numbers 12 and 13 from 72. Have a good one, guys. See you guys tomorrow. Bye. 12 and 13 of page 72. Yes. Let's see.
71, all of it?
71, all of it. And page 72, 13 and 12. Have a good one, guys. See you guys tomorrow. Bye.